Hello, welcome to 1.5 atomic structure and electronic configuration. Okay, welcome to the AP chemistry. We um, so far we have done initial fundamentals. Now we are entering into the atomic structure and try to understand a few concepts about Coulomb's law and how to write electronic configuration, what are the periodic properties, and so on. Okay, so the first is as we know earlier that the electrons that revolve around the electrons revolve around the nucleus and the protons are inside the nucleus, and you have a specific distance, and the radius is nothing but the electrons uh, where they are located far away from the nucleus. Okay, and the most important law that defines is what is called as the Coulomb's law. The Coulomb's law is the force of attraction is equal to k q1 q2 by d square. So in other words, F is proportional to the charge and directly proportional to the charge and inversely proportional to the distance. Okay, the square of the distance. So it means the higher the charge, the higher the force of attraction. Okay? The higher the charge, the higher the force of attraction. If you have very lot of protons here, it is going to attract the electrons very well. Okay, the higher the distance, less the force. That means if the electrons are far away, if it is in the second orbit or it's in the third orbit, it is going to have less force of attraction. Okay, so this is very important. Okay, you should have a clear picture about this. And when you have electrons, okay, the nucleus is at the center. You have several orbitals. Okay, orbit 1, orbit 1, orbit 2, orbit 3, orbit 4. The outermost electrons are called as the valence electrons. Okay, this is the inner core electrons that revolve around. Okay, the farthest the electron, okay, you have less attraction and more energy. Okay, they have more freedom to move because they are not attracted by the nucleus. Okay, these inner electrons when they revolve around, they are going to give what is called as a shielding effect. Okay, by which these electrons are more free to move. So that means we can easily take out these electrons compared to these electrons. What is ionization energy? The ionization energy means the energy required to remove an electron from the outermost atom of a gaseous species. So you take out an electron from an atom. Okay, to make that, you have to first make it as a gaseous species, and then you take out the first electron. This is called as the first ionization energy. The second ionization energy means take out the second electron from that species. Okay, so A plus become 2, A2 plus, and then another electron is coming. Okay. Now let's compare the ionization energy values, okay, for these elements. Now we are comparing these elements because these elements are in the same group. Hydrogen, lithium, sodium, potassium is in the first group, and the helium, neon, argon, krypton is on the rightmost end. Now, when you look at the electronic configuration, the electronic configuration looks like this. Hydrogen is 1s1, helium is 1s2. So this is filled. Lithium is 1s2, 2s1. Okay. Neon is 1s2, 2s2, 2p6. Now this is also full. Here, sodium is 1s2, 2s2, 2p6, 3s1. Here, the overall end is 1s2, 2s2, 2p6, 3s2, 3p6. So if you see all these things at the end, they have a filled shell. It is very hard to take out these electrons. And you see these numbers rising very high, 2000, 2000, 1500 compared to these smaller numbers. So these are the data that tells us that when you have one electron in the outermost shell, this is relatively easier to take those electrons, spending 496 kilojoules per mole for 1 mole. If I use 496 kilojoules mole, I can take an electron from sodium compared to a filled shell of argon of 1000 to spend 1520 kilojoules per mole. For 1 mole, I'm using triple the amount. Okay. For neon, I'm using at least 4 times the amount. Okay. So it tells us the electrons are arranged in shells or orbits. Okay. So they are not randomly revolving around anywhere they want. So in this chapter, we have to understand what is electronic configuration. Okay, so we have to know to write the electronic configuration, both the electronic configuration, writing both the shorter form and the longer form. If for sodium, I can write either 1s2, 2s2, 2p6, 3s1, or I can write 1s2, 2s2, 2p6 can be simplified as neon, and then I can say the difference change is only 3s1. I should know this, how to write this. The second one is to know isoelectronic species. Iso means same. Iso means same. Electronic means the same number of electrons. If you compare argon and Cl minus, an anion, and a Ca2 plus cation, all of them has the same electronic configuration because they have the same number of electrons, 18, 18, 18. But they have different number of protons, 18 proton, 17 proton, and 20 proton. But they have the 18 electrons. So their atomic radii or the ionic radii is going to be different for these species. So that you should have a very clear picture about. Okay, the number of protons versus electron ratio is going to change the radii. This is going to affect many atomic properties. Okay, and the d block elements and cations. Okay, if when you fill electrons, you are going to fill in the form of Aufbau order. Okay, you are going to fill electron. When you take iron, topic number 26, you are going to fill till argon 1s2, 2s2, 2p6, 3s2, 3p6, and then fill 4s2 and then 3d6. But when the iron loses 2 electron, it is not going to lose the electron from 3d. It is going to lose the electron from 4s. Okay, so it's going to always lose the electron from the outermost shell. But when you fill them, where did we fill? We fill the 4s first, which was outside, and then we fill the higher energy 3d later on. That's how we fill. We put the electrons. The electrons we add. But when we take out the electrons come out from 4s. Okay, so we should have a very, very clear picture about this. This question is often asked in AP. It's very high priority question. And also writing orbital diagram. The electrons, when they occupy in an orbital, they always try to they maintain freedom. Okay, so 1s2, 2s2, these 4 electrons, when they add the first, they go and take individual pockets. The first 3 electrons go there. When there is no other space, they come and pair up here. Okay, this is like going inside a train and you try to take the window seat. And when there is no other spots available, you go and pair up with someone and sit next to them. So that's how the electrons also behave in the lower level. Okay, so that is very important. So when you understand this 1.3, the 1.5 is very easy.